these kind of problems. The answer will involve x's and y's. Now, just so you know, can you guys tell me what is a point which solves this equation? Let me say 1, hopefully that'll work, comma something. If I put x equal to 1, what could I choose for y and solve this? That might not work. Let's try 2. So we'd have 2 times y plus y squared equals to 4. Could we choose a y that solves that? I'm trying to find a point on this thing. Listen, we could get out the Desmos and graph this. Oh, this computer's like so very dead. Can you think of a y that solves this? Is it possible? Oh, I don't know. That's y squared plus 2y minus 4 equal to 0. So we could use y is equal to minus 2 plus or minus the square root of, oh, why am I doing it that way? This is y plus 1 squared, right? Minus 5. So y plus 1 squared equals to 5. So y plus 1 is plus or minus root 5. So we could use y equals to minus 1 plus root 5. So in other words, the point 2 comma minus 1 plus root 5, this is a point. This is a point on xy plus y squared equal to x squared, all right? I wanted to find that point because I want to show you we can find the equation to the tangent line at that point. How do we do it? Well, so that's the point that we're going to find the tangent line through, right? What's the slope of the tangent line? Well, it's dy dx. And we just have to evaluate at the point 2 minus 1 plus root 5, right? So what that means is we take 2 times 2 minus y, which was what? Minus 1 plus the square root of 5, and divide by 2 plus 2 times minus 1 plus the square root of 5. Whatever that number is, that's the slope of the tangent line to this graph at that point. I don't know what that number is right offhand. This computer will wake up. Well, let me not. That would be a waste of our time, actually. So let me call this number m, right? So then y equals to minus 1 plus the square root of 5 plus m times x minus 2. That is the equation of the tangent line to that graph at that point. So we can use implicit differentiation to find. Oh, goodness gracious. Let me do another example. Suppose we have the square root of xy equals to the sine of x. Find dy dx. All right. So here we go. d dx of the square root of xy is equal to d dx the sine of x. All right. So this is 1 over 2 square root of xy, right? And then we have to multiply by the chain rule the derivative of xy. What's the derivative of a sine x on the other hand? Just cosine, right? Now, derivative of xy, that is a product of functions of x. So we must use the product rule. So we get dx dx, which is 1. So I get y plus x dy dx. And now we can solve for dx dy. So we have x over twice the square root of xy dy dx equals to cosine x minus y over 2 square root of xy. And so dy dx is equal to 2 square root of xy over x times cosine of x minus y over 2 square root of xy. Of course, you could multiply that out and simplify it if you wanted to, but there it is. Do you guys have anything right after class today?
Yeah, I have practice.
Curses. All right, well, I have time for one example. So this is the first of, we're going to do this over and over and over again, all right? What I'm about to show you, this trick. So check it out. So we want to know what the derivative with respect to x of inverse tangent of x is. We don't know this yet. All right? So here's the technique. You write y equal to inverse tangent of x. All right? Now then, what happens if we take the tangent of that equation? We get tangent of y equals to the tangent of the inverse tangent of x, which is just what? It's just x, right? Now, this implicitly defines y as a function of x. So we can implicitly differentiate this. And see, we have d dx of tangent y equals to dx dx, right? Remember what the derivative of tangent was? We worked it out last time. It was secant squared, right? But we're differentiating tangent y with respect to x. So we get secant squared y times what? Times dy dx equals to 1. What are we trying to find? We're trying to find dy dx. That is the question. So solve for dy dx. What do you got? 1 over secant squared y. But do you remember the identity for tangent? Remember the identity? Secant 1 plus tangent squared y equals to secant squared. So you see this is 1 over 1 plus tangent squared y. But what is tangent squared y? Tangent squared y is x squared, because tangent of y is x. So this is 1 over 1 plus x squared. And so thus we derive the derivative with respect to x of the inverse tangent of x is 1 over 1 plus x squared. And this technique that I've just shown you, we're going to be able to use to calculate the derivatives of inverse sine, inverse cosine, inverse hyperbolic cosine, the natural log, all of the inverse functions we don't have derivatives for yet, we can use this technique to calculate their derivatives. So, to me, this is one of the major applications of implicit differentiation. But anyway, that's it for today, guys. Don't mean to keep you from your other stuff.